Hello. Today we are looking at slope-intercept form. This is a common form for linear functions. The formula for it is y equals mx plus b. X and y correspond with coordinates on a coordinate grid, the x-axis and the y-axis. The m and the b both stand for different pieces within that. The m then is commonly known as slope. Let's see. Slope. It's also known, as we know, as rate of change. At what rate is it changing? And I'll show you an example here coming up. Or in layman's terms is what? It's going what? It's going up by. Oh my goodness, going up or down by. This is what you'll hear me say in class. For example, how fast was it going? How much money was he losing? That's what it's going up or down by. That's what your number that goes in the M will represent. The B then, let's do a little bit of this. So this is your M. Your B over here is known as your y-intercept. Y-intercept then is the place at which, right, intercept, where the graph passes through coordinate, the y-axis. In layman's terms, where does it start? Again, I'll show you an example here coming up as to how we can use both of these. For slope-intercept, an easy way slope-intercept form is an easy way to graph an equation. So we know that slope-intercept was y equals mx plus b. Let's throw some numbers in there. For example, I know I could have y equals 3x minus 4. I could have y equals negative 2/3 plus 7. Both of those are still in slope-intercept form, where it's real easy to see the slope and real easy to see the y-intercept. These next two, you'll have to rework to get the y by itself. Let's see, how about we do 12x minus y equals, let's say 10. Okay, so in order to change this into this red equation, we'd have to get the y by itself. So let's subtract 12x minus 12x. And now I have a negative y equals, I'm going to put the 12x first, just to try to get the x in front of the unit, minus 12x plus 10. I still have a negative y. That's the same thing as a negative 1. So I'm going to divide by a negative 1. Divide this whole side by a negative 1. Negative 1. Therefore, now I see y is in fact equal to 12x minus 10. Now it's easy to see the slope and the y-intercept. Be careful in terms of trying to find the slope before you have it equal to y. They'll always try to trick you with that. Let's see. Slope-intercept is real easy to graph. I'm going to do this equation right here and get this one graphed. First thing you're going to want to do is start with your y-intercept. So I know my y-intercept is 4. I guess I should label my graph. I'm just going to go by ones. This is a negative 1, negative 2, negative 3, negative 4. That's a 1, 2, 3, 4, and 1, 2, 3, 4. And you guys get the bit. Negative 1, negative 2, negative 3, negative 4. Okay, whew. Make this 1. All right. Y-intercept is going to be at a negative 4. Remember, don't forget this negative. This one would have been at a positive 7. So right down here at negative 4 is where my first point is going to be. And we should use a different color. How about red? I'm going to put a dot right here at my y-intercept. I know my slope then is going to be 3 over 1, meaning I'll go up 3 over 1. There's another point. Up 3 over 1. I'm going to throw a few points down here. Down 3 over 1. I'm just making a few of our slope triangles, which we've worked on in class. Next up, take your straight edge. I'm going to choose the one with the arrow. See how good I can get these lined up here. Oops, I ran out of room. Continue this. Oh, that's there we go. That works out. And of course then, since we could have kept going negative, we definitely want to make sure we have an arrow going that way as well. So that was a real quick way to graph an equation, is when you have it in the y-intercept form. Last example is this word problem. I want to try to create a y equals mx plus b. See if I can write equation representing this situation here. Okay. Sean is 100 feet below sea level and is ascending at a rate of 5 feet every 2 minutes. If we go back, then we notice that the slope then is the rate of change, or what it's going up or down by. In this case, he's going up because of the word ascending. So I know that my rate of change is 5 feet every 2 minutes. Let's write that as a fraction. He's going up 5 feet every 2 minutes. Okay, now we can definitely label it over here. When we put it into the equation, we won't need to label it. So far I have y equals, my m then was 5 over 2. You'll notice we don't change it to a mixed number when we're doing slope-intercept form. You can leave it just as an improper fraction, times x, plus this b then is going to be where he started, or your y-intercept. So that's where I like the layman's term. So the 100 feet, so this 100 is going to be in there. Now, did you see it? Below sea level. Think about what it should look like before I'm writing it. Oh, you're right. Negative 100. So you could say equation that looks like this. Y equals 5 halves x plus a negative 100, or y equals 5 halves x minus 100. Both of those mean the same thing.